Okay, let's work out a few examples of the exponential probability distribution. A certain manufacturer of small electric motors obtains empirical data from sampling that shows the service life of its motors to be exponentially distributed with an average service life of 100 hours. What is the probability that a randomly selected electric motor will fail within the first 50 hours? Okay, so let's say we have an exponentially distributed random variable y that describes the time to failure. Okay, because the time to failure would be the service life, essentially. Okay, service life of any kind of system would be its time till failure occurs. And we see that we have an average service life of 100 hours. Okay, so we see one failure per 100 hours. Okay, average service life of 100 hours is one failure per 100 hours. That is our rate, lambda. Okay, back to our other notation that we've seen in other textbooks, we could say that beta is 100 hours. Okay, that's the average interval until failure occurs. But we like to use this lambda notation. So 1 per 100 hours, which is 0.01 fails per hour. Okay? And we want to know what's the probability that a randomly selected electric motor will fail within the first 50 hours. Okay? What's the probability that the time to failure is less than 50 hours in the first 50 hours? So what's the probability that y is less than 50? So let's draw out our distribution. Here we have random variable y, and the exponential probability distribution function looks something like this. So here's f of y. And we want to know what's the probability that y is less than 50. Here's 50, and we want this probability. Okay? So what do? We can integrate f of y in between the lower bound, 0, and our value 50. Okay? Probability that y is less than 50 is equal to the integral between 0 and 50 of f of y dy. F of y is lambda e to the minus lambda y. That is 0.01 e to the minus 0.01 times y dy. Okay? This is also equal to the cumulative distribution, okay, evaluated at 50. So this is equal to capital F of 50. Okay, remember, capital F of y is 1 minus e to the minus lambda y. So this would be 1 minus e to the minus 0.01 times 50. Okay? And if we work that out, we should get a probability of 0.3935. Okay? So what's the probability that a randomly drawn motor will fail in the first 50 hours? 0.3935. That is, whenever we see, on average, one failure every 100 hours, the proportion of motors that fail in the first 50 hours is roughly 0.4. 40% of motors are going to fail in the first 50 hours.